Okay, hello Twitch, hello Internet. Thanks for stopping by on this Saturday night. Tonight we are going to be learning about the Rust programming language. This is happening because 2 weeks ago when I was streaming some Python Pygame stuff, a viewer stopped in and wrote in the chat and said, "Hey, I'll follow you if you promise to learn Rust." Oh, hello, Sammy. Good kitty. Are you here to stream with me? Good kitty. Ah, didn't expect that. Sorry, all you can see of him is the back of his head. The back of him. Let's see if we can improve that. Oh, there he goes anyway. Maybe we'll get another visit from him shortly. Let's get a 30-minute timer going. And let's get into the Rust programming language. This is the book, The Rust Programming Language by Sneeve Kalabnik and Carol Nichols with contributions from the Rust community. This version of the text assumes you're using Rust 1.62, release 2022-630 or later. See the installation section of Chapter 1 to install or update Rust. Well, we'll come to that later. The HTML format is available online. Several community translations are available. This text is available in paperback. All right, let's move forward. Am I going to read the foreword? Yeah, I'll read the foreword. Why not? Forward. It wasn't always so clear, but the Rust programming language is fundamentally about empowerment. No matter what kind of code you are writing now, Rust empowers you to reach farther, to program with confidence in a wider variety of domains than you did before. Take, for example, systems-level work that deals with low-level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane, accessible only to a select few who have devoted the necessary years learning to avoid its infamous pitfalls. And even those who practice it do so with caution, lest their code be open to exploits, crashes, or corruption. All right, 1 second. Get everything set right. Rust breaks down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need to dip down into the lower level control can do so with Rust, without taking on the customary risks of crashes or security holes, and without having to learn the fine points of a fickle toolchain. Better yet, the language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. That sounds good. Programmers who are already working with low-level code can use Rust to raise their ambitions. For example, introducing parallelism in Rust is a relatively low-risk operation. The compiler will catch the classic mistakes for you. And you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce crashes or vulnerabilities. But Rust isn't limited to low-level systems programming. It's expressive and ergonomic enough to make CLI apps, web servers, and many other kinds of code quite pleasant to write. You'll find simple examples of both later in this book. Working with Rust allows you to build skills that transfer from one domain to another. You can learn Rust by writing a web app, then apply those same skills to target your Raspberry Pi. This book fully embraces the potential of Rust to empower its users. It's a friendly and approachable text intended to help you level up not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So dive in, get ready to learn, and welcome to the Rust community. Nicholas Matsakis and Aaron Turin. Hope I got their names close to right. Introduction. Note, this edition of the book is the same as the Rust programming language available in print and ebook format from No Starch Press. I'll stick with the online version. Welcome to the Rust programming language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict. Through balancing powerful technical capacity and a great developer experience, Rust gives you the option to control low-level details such as memory usage without all the hassle traditionally associated with such control. One second, I need to adjust something over here. Okay, cool. Who is Rust for? Rust is ideal for many people for a variety of reasons. Let's take a look at a few of the most important groups. Teams of developers. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of systems programming knowledge. Low-level code is prone to a variety of subtle bugs, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. In Rust, the compiler plays a gatekeeper role to refusing to compile code with these elusive bugs, including concurrency bugs. That seems like a bold claim, but I'll keep reading and see what we find. By working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. Rust also brings contemporary developer tools to the systems programming world. Cargo, the included dependency manager and build tool, makes adding, compiling, and managing Rust dependencies painless and consistent across the Rust ecosystem. Rust FMT ensures a consistent coding style across developers. The Rust language server powers integrated development environment integration for code completion and inline error messages. By using these and other tools in the Rust ecosystem, developers can be productive while writing systems-level code. Students. Rust is for students and those who are interested in learning about systems concepts. Using Rust, many people have learned about topics like operating systems development. The community is very welcoming and happy to answer student questions. Through efforts such as this book, the Rust teams want to make systems concepts more accessible to more people, especially those new to programming. Companies. Hundreds of companies, large and small, use Rust in production for a variety of tasks. Those tasks include command line tools, web services, DevOps tooling, embedded devices, audio and video analysis and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things applications, machine learning, and even major parts of the Firefox web browser. Open source developers. Rust is for people who want to build the Rust programming language, community, developer tools, and libraries. We'd love to have you contribute to the Rust language. People who value speed and stability. Rust is for people who crave speed and stability in a language. By speed, we mean the speed of the programs that you can create with Rust, and the speed at which Rust lets you write them. The Rust compiler's checks ensure stability through feature additions and refactoring. This is in contrast to the brittle legacy code in languages without these checks, which developers are often afraid to modify. By striving for zero-cost abstractions, higher-level features that compile to low-level code as fast as code written manually, Rust endeavors to make safe code be fast code as well. The Rust language hopes to support many other uses as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed and ergonomics. Give Rust a try and see if its choices work for you. Who this book is for. This book assumes that you've written code in another programming language, but doesn't make any assumptions about which one. We've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. Danny McGee says, why would you ever promise such a thing? Well, it gets lonely out here, and I'm a shill for followers. That's the whole reason. Now, Dandy McGee, by the way, thanks for stopping by and saying hello. What do you think I should be learning instead of Rust? Okay, back to the book while we wait for that. We don't spend a lot of time talking about what programming is or how to think about it. If you're entirely new to programming, you'll be better served by reading a book that specifically provides an introduction to programming. Promise me, so Danny McGee goes on, promise me you won't learn Rust and I'll stay, and I'm here and they're not. And they're not, so I'm more important. I have no problem with Rust, go for it. I for learning in general. Wait, so are you telling me to learn something other than Rust? You are for learning in general. Okay, that's good. I'm also for learning in general, that's why I'm here. Well, if you want to suggest something else, I'll be all ears, but until that time, I'm going to keep chugging through this verbose introduction. How to use this book. In general, this book assumes that you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters, and earlier chapters might not delve into details on a topic. We typically revisit the topic in a later chapter. You'll find two kinds of chapters in this book: concept chapters and project chapters. Dandy McGee says, just being sarcastic, if you learn, you improve, no matter what you learn. Very good. You'll find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you'll learn about an aspect of Rust. In project chapters, we'll build small programs together applying what you've learned so far. Chapters 2, 12, and 20 are project chapters. The rest are concept chapters. Oh, the GitHub command. I really hope that still is working. I'll be embarrassed if it's not. Bot is dead. That's unfortunate. That's embarrassing. Sorry about that. Next stream, I promise I'll have it up. You'll be the bot. Thank you for filling in. These things are important. Okay, going forward here. Chapter 1 explains how to install Rust, how to write a Hello World program, and how to use Cargo, Rust's package manager and build tool. Chapter 2 is a hands-on introduction to the Rust language. Here we cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, Chapter 2 is the place for that. At first, you might even want to skip Chapter 3, which covers Rust's features similar to those of other programming languages, and head straight to Chapter 4 to learn about Rust's ownership system. However, if you're a particularly meticulous learner who prefers to learn every detail before moving on to the next, you might want to skip Chapter 2 and go straight to Chapter 3, returning to Chapter 2 when you'd like to work on a project applying the details you've learned. I think I'm just going to go straight through in order. That seems like the safest way to go. Chapter 5 discusses structs and methods, and Chapter 6 covers enums, match expressions, and the if-let control flow construct. You'll use structs and enums to make custom types in Rust. In Chapter 7, you'll learn about Rust's module system and about privacy rules for organizing your code and its public application performing interface. I'm going to say it right this time. Application Programming Interface, API. Chapter 8 discusses some common collection data structures that the standard library provides, such as vectors, strings, and hash maps. Chapter 9 explores Rust's error handling philosophy and techniques. Gosh, this goes on. I'll still read it. Let's see, where was I? Philosophy and techniques. Dandy McGee asked, did you delete your Twitter account or just spell it wrong? I may have renamed it at some point. See, the annoying thing is error codes was already taken. And I think this is the current iteration of it. Chapter 10 digs into generics, traits, and lifetimes, which will give you the power to define code that applies to multiple types. Chapter 11 is all about testing, which even with Rust safety guarantees is necessary to ensure your program's logic is correct. In Chapter 12, we'll build our own implementations of a subset of functionality from the grep command line tool that searches for text within files. That should be fun. For this, we'll use go away. For this, we'll use many of the concepts we discussed in the previous chapters. Gotta update your bio link, says Danny McGee. That is true. I do need to update that. I'll get on that after this stream. Okay, build our own grep command line tool that searches for text within files. For this, we'll use many of the concepts we discussed in the previous chapters. Chapter 13 explores closures and iterators, features of Rust that come from functional programming languages. In Chapter 14, we'll examine cargo in more depth and talk about best practices for sharing your libraries with others. Chapter 15 discusses smart pointers that the standard library provides and the traits that enable their functionality. In Chapter 16, we'll walk through different models of concurrent programming and talk about how Rust helps you to program in multiple threads fearlessly. Chapter 17 looks at how Rust idioms compare to object-oriented programming principles you might be familiar with. Chapter 18 is a reference on patterns and pattern matching, which are powerful ways of expressing ideas throughout Rust programs. Chapter 19 contains a smorgasbord of advanced topics of interest, including unsafe Rust, macros, and more about lifetimes, traits, types, functions, and closures. Dandy McGee says, I found Fix-It. It wasn't disappointed. It wasn't disappointed? That might be a typo there. Let me know. In Chapter 20, we'll complete a project in which we'll implement a low-level multi-threaded web server. Cool. Finally, some appendices contain useful information about the language in a more reference-like format. Appendix A covers Rust's keywords. Appendix B covers Rust's operators and symbols. Appendix C covers derivable traits provided by the standard library. Appendix D covers some useful development tools. And Appendix E explains Rust's additions. In Appendix F, you can find translations of the book, and in Appendix G, we'll cover how Rust is made and what nightly Rust is. There is no wrong way to read this book. If you want to skip ahead, go for it. You might have to jump back to earlier chapters if you experience any confusion, but do whatever works for you. Dandy McGee says, I wasn't disappointed. Fix to that typo there. And also says, and appendix, without a letter, is an irrelevant organ which we won't cover in this book. Thank you for the addition. An important part of the process of learning Rust is learning how to read the error messages the compiler displays. These will guide you toward working code. As such, we'll provide many examples that don't compile along with the error messages the compiler will show you in each situation. Know that if you enter and run a random example, it may not compile. Make sure you read the surrounding text to see whether the example you're trying to run is meant to error. Ferris will also help you distinguish code that isn't meant to work. I guess Ferris is the Rust logo. Question mark, this code does not compile. I was going to say hands up, but it's definitely claws up. Claws up means this code panics, and one claw up means this code does not produce the desired behavior. What does it mean for code to panic? In most situations, we'll lead you to the correct version of any code that doesn't compile. Source code. The source files from which this book is generated can be found on GitHub. Cool. Getting started. Let's start your Rust journey. There's a lot to learn, but every journey starts somewhere. In this chapter, we'll discuss installing Rust on Linux, macOS, and Windows, writing a program that prints Hello World, using Cargo, Rust's package manager and build system. Danny McGee says, panic equal fatal error causes an intentional crash abort. Interesting. I imagine the book will give me some more details on that as we go along. Installation, the first step is to install Rust. We'll download Rust through RustUp, a command line tool for managing Rust versions and associated tools. You'll need an internet connection for the download. Note, if you prefer not to use RustUp for some reason, please see other Rust installation methods page for more options. I'm going to stick with the main option. The following steps install the latest stable version of the Rust compiler. Rust stability guarantees ensure that all the examples in the book that compile will continue to compile with newer Rust versions. The output might differ slightly between versions because Rust often improves error messages and warnings. In other words, any newer, stable version of Rust you install using these steps should work as expected with the content in this book. Command line notation. In this chapter and throughout the book, we'll show some commands used in the terminal. Lines that you should enter in a terminal all start with $. You don't need to type in the $sign character, it's the command line prompt shown to indicate the start of each command. Lines that don't start with $ typically show the output of the previous command. In addition, PowerShell specific examples will use sideways caret rather than $sign. If you're using Linux or macOS, open a terminal and enter the following command. The command downloads a script and starts the installation of the RustUp tool, which installs the latest stable version of Rust. You might be prompted for your password. If the install is successful, the following line will appear. Rust is installed now. Great. Okay, let's read this thing. curl proto https tlsv 1.3 https sh.rustup.rs looks legit. -ssf, I don't know what those mean, but we'll trust it. Here we go. One, proceed with installation default. Sure. Welcome to Rust. This will download and install the official compiler for the Rust programming language and its cargo manager, Cargo. RustUp metadata and toolchains will be installed into the RustUp home directory located at users.ericanderson.rustup. This can be modified with the RustUp home environment variable. The Cargo home directory is located at users.ericanderson.cargo. This can be modified with the Cargo home environment variable. The Cargo, rustc, and RustUp and other commands will be added to Cargo's bin directory located at users.ericanderson.cargo bin. This path will also then be added to your path environment variable by modifying the profile files located at the following. Sure. You can uninstall anytime with RustUp self uninstall, and these changes will be reverted. Current installation options: default host triple, default toolchain, stable default, profile default, modify path variable, yes. Okay, continue. Proceed. Okay, downloads the script. You'll also need a linker, which is a program that Rust uses to join its compiled outputs into one file. It is likely you already have one. If you get linker errors, you should install a C compiler, which typically will include a linker. A C compiler is also useful because some common Rust packages depend on C code and will need a C compiler. Rust is now installed. Great. To get started, you may need to restart your current shell. Dandy McGee snipes from the corner. Generating bitcoins. Please wait. Generated 1 bitcoin for the Rust development team. Thank you for installing Rust. Please wait. How do I get on the Rust development team? Okay, we can open a new tab that should do this. Daddy points out, well, you're developing in Rust right now, so I suppose you're already on it. Yes, but how do I get a share of that Bitcoin I just generated? That's the important part. On macOS, you could get a C compiler by running xcode select -- install. I may already have that. Linux users should generally install GCC or clang according to their distribution's documentation. For example, if you use Ubuntu, you can install the build essential package. Installing Rust up on Windows, skip. Troubleshooting, to check whether you have Rust installed correctly, open a shell and enter this line, rustc -- version. West 1.64. Daddy says, oh, that's impossible. It's not for you. Go back to work, peasant. Yeah, sure. You should also see the version number, commit hash, and commit date for the latest stable version that has been released in the following format. Rust 1.64.0, commit hash. Oh, wait, what did I just do? 2022-9/19. Sure. If you see this information, you have installed Rust successfully. If you don't see this information, check that Rust is in your path system variable as follows. Okay, that's fine. If that's all correct and Rust still isn't working, that's not relevant to me. Updating and uninstalling. Once Rust is installed via rust up, when a new version of Rust is released, updating to the latest version is easy. From your shell, run the following update script, rust up update. To uninstall Rust and rust up, run the following uninstall script from your shell, rust up self uninstall. So if I really get annoyed that they're taking up my processing power on Bitcoin, then it's good to know I can get rid of it that way. Local documentation. The installation of Rust also includes a local copy of the documentation so you can read it offline. Run rustup.doc to open the local documentation in your browser. I'll just use this online documentation. Anytime a type or function is provided by the standalone library and you're not sure what it does or how to use it, use the Application Programming Interface API documentation to find out. Okay. We're coming close to 30 minutes, so it's close to break time, but I'm going to keep going. Danny McGee says, nope, the Bitcoin generator is installed forever. You can only uninstall the useful parts. Dang. Okay, the Rust programming language. Hello world. Now that you've installed Rust, let's write your first Rust program. It's traditional when learning a new language to write a little program that prints hello world to the screen, so we'll do the following. So we'll do the same here. Note, this book assumes basic familiarity with the command line. Rust makes no specific demands about your editing or tooling or where your code lives. So if you prefer to use an integrated development environment instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details. The Rust team has been focusing on enabling great IDE support via Rust Analyzer. See Appendix D for more details. Danny McGee has a challenge. It says, challenge, come up with something more clever to print. I don't know. I don't know if I can do that. Hello World is already pretty clever. I mean, look, it's got punctuation and everything. Creating a project directory. You'll start by making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercise and projects in this book, we suggest making a projects directory in your home directory and keeping all your projects there. I don't think I already have a projects directory, so we can do that. CD projects. I usually print goodbye cruel world. Oh. Make directory hello world cd hello world. For Windows, CMD, enter this. Yeah. Writing and running a Rust program. First, make a new source file and name it main.rs. We'll use vim for now. Vim main.rs. Rust files always end with the .rs extension. If you're using more than one word for your file name, the convention is to use an underscore to separate them. For example, use hello underscore world.rs rather than hello world.rs. Open the main.rs file you just created and enter the code in listing 1.1. Danny McGee says, Vim? Dang, he's serious. That's right, I'm serious. I don't remember why I learned Vim, but now that I have, I kind of like it. I'm definitely not a power user, but I've completed the Rust tutorial, not the Rust tutorial, the Vim tutorial, so I know the basic navigation and I can kind of stumble my way through editing. And I'm expecting that we'll have syntax highlighting in here. We'll see. FN, yes, look, we have syntax highlighting. FN main, braces, and this is interesting. It tells us to do indents, so I'm immediately thinking like Python land, but, well, I have some thoughts, but we'll see where this goes. Println exclamation point. That's interesting. Quote, hello, world. What can I say? I'm a rule follower. I'm not going to change that. And we'll start with a new line. Write and quit. Hit the file and go back to your terminal window in project's hello world directory on Linux or Mac OS. Enter the following commands to compile and run the file. Rust C main.rs. And what did that do? That created a main executable. We'll do. Let's just do ls. What is happening on my phone? Danny McGee points out, Rust is rather unique in that indentation is a vital part of the syntax. Most of the languages merely do it for readability, but are not sensitive to the exact level of indentation like Python. Rust is one such language. That's good information. What I was thinking ahead towards is whether Rust FMT is going to enforce a certain level of indent in the code to make it more readable. Maybe I'll try playing around with it and see what happens if I take out the white space. But anyway, /main. Hello world, it works. Regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to troubleshooting part of the installation section for ways to get help. Hello world does happen. If hello world did print, congratulations, you've officially written a Rust program. That makes you a Rust programmer. Welcome. Thanks, Rustbook. Now, let's play with this and see how we can break it. I'll start by taking away the closing brace. This probably won't compile. I'm used to Python where you can just run stuff and it can fail hilariously when you try to run it. Danny McGee points out that of this here, it runs but is disappointingly unclever. Sorry to disappoint. Okay, rust c main.rs. Error, this file contains an unclosed delimiter. main.rs 42 1 fn main unclosed delimiter. That's kind of nice. Aborting error, aborting due to previous error. Vim main.rs. So we'll put that back. Oops. Forgot how to type for a second there. Now, what if I take away that? I assume this will work just fine. Dang, I kind of want to do a. Oh well. Rust c main.rs. Yeah, that works fine. Wait, what? Oh, main.rs is the. Okay, I see what I did there. Let's expand this a little bit and do an LL. Expand it a little bit more. Okay, main.rs is the source code file, and it has permissions read, write, read. But main is the executable, and it has permissions read, write, execute, or read, execute. So that's when I try to run the source code. It's so different from Python, where in Python you just go python main.py and it runs it. This is a different way of thinking of things. I'll have to get used to it a little bit. Okay. I also want to see, I already know this is going to work, I think, but no, I wanted, well, whatever. And we're showing that I'm not as great with Vim as I'd like to be. Oh, I did the wrong thing there. There we go. So now it's all on one line, even though it appears on two lines. Rust c main.rs and /main. Hello world. Okay, enough with hello world. Anatomy of a Rust program. Let's review this hello Rust program in detail. Here's the first piece of the puzzle. fn main parens braces. Danny Mookie is saying, you can enter this Vim command to run it from within Vim. Vim rustc main.rs and n./main, or rustc% and n./main, where % is short for the current file I'm editing. That's kind of neat. So, I'm assuming it comes after the colon, because that's typically how you do commands in Vim. So exclamation point rustc main.rs and n./main. Press enter or type command to continue. And then we come back to here. And then I can do it again.
Yeah.
Cool. This is, like, mildly clever, maybe. But anyway, now I can do that command again. Oh, interesting. There was no write since the last change, so I have to write first. Then I can do that command. Danny B says, yep, the exclamation point just tells them to run any shell command. Pretty cool. What if I wanted it to appear down here at the bottom of my rest? What if I wanted those outputs to appear down here at the bottom of my Vim window instead of switching back to the terminal? Also, it's time to now Google it. Yeah, I won't worry about that now. What I will do is jump to the BRB screen because it's been the 30 minutes time. And I need to give my brain a break. Pomodoro? Yeah, that's basically what this is. I've got a 30-minute thing that I just took away, and this is a 5-minute. Little 5-minute guy. Yep, got the BRB logo going on. Yeah, I'll be right back. Okay, it just so happens I'm feeling energized, so we are going to get right back into it, even though the full 5 minutes of rest time has not gone fully observed. Let's go to the scene. And there's our next 30 minutes. Here we go. Okay, that's right, we're reviewing. Oh, I can run this? What does that do? No output. Huh. Wonder how you do comments in Rust. I'm sure it'll tell me that soon. These lines define a function named main. The main function is special. It is always the first code that runs in every executable Rust program. Here the first line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. The function body is wrapped in curly braces. Rust requires curly braces around all function bodies. It's good style to place the opening curly braces on the same line as the function declaration, adding one space in between. Note, if you want to stick to a standard style across Rust projects, you can use an automatic formatter tool called Rust FMT to format your code in a particular style. More on Rust FMT in Appendix D. I might take a look at Appendix D, honestly. The Rust team has included this tool with the standard Rust distribution like Rust C, so it should already be installed on your computer. Let's see what Rust format will do. Appendix D, useful development tools. In this appendix, we'll talk about some useful development tools, automatic formatting, the Rust FMT tool, reformats your code according to the community code style. Many collaborative projects use Rust FMT to prevent arguments about which style to use when writing Rust. Everyone formats their code using the tool. To install Rust FMT, I don't think I have to install Rust FMT. It just told me that. Note, if you want, the Rust team has included this tool with the standard Rust distribution like Rust C, so it should already be installed on your computer. Okay, how do I use it though? This command gives you Rust FMT and Cargo FMT, similar to how Rust gives you Rust C and Cargo. To format any Cargo project, enter the following. Running this command reformats all the Rust code in the current crate. This should only change the code style, not the code semantics. For more information on Rust FMT, see its documentation. But I haven't learned what Cargo is yet, so this isn't very useful. Let's quit Vim and try Rust FMT main.rs. Let's cat main.rs. I don't know, we'll do Vim. And make it not that way, then do another Rust FM. Cat main.rs. Okay, it's like that without the indent. And if I do Rust FMT, ooh, can't type. Rust FMT main.rs. Karki, hello. Just Cargo FMT should be all good. But I haven't set up a Cargo whatever thing, so I wasn't sure if that would work, but let's try it. You're saying Cargo FMT. Fargo, oops. Yeah, see, that's not going to work because I haven't set up a package yet. Cargo metadata exited with an error could not find cargo.toml in blah 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 projects hello world or any parent directory. So that's not going to work for now. But where are we? Oh yeah. Karki says, yeah, you got ahead of me a little bit. I haven't set up a Cargo. I don't even know how to say that I haven't done the thing with Cargo, but I haven't done it yet. Okay. So that's for standard formatting. I can just do Rust FMT main.rust, and then we can do Rust C main.rust, and finally /main. And that took longer than I would have expected. But we got it, so that's good. Okay, the body of the main function holds the following code. Oops, what did I do? This line does all the work of this little program. It prints text to the screen. There are 4 important details to notice here. First, Rust style is to indent with 4 spaces, not a tab. Well, for the purpose of Rust development, that kills that particular argument. Hey, Dandy McGee, thanks for that follow. Did that come up on the screen? I think it must have. I just didn't look close enough to see it. Second, println exclamation point calls a Rust macro. If it had called a function instead, it would have been entered as println without the exclamation point. We'll discuss Rust macros in more detail in chapter 19. For now, you just need to know that using an exclamation point means that we're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. Interesting. Third, you'll see the hello world string. We pass this as an argument to println, and the string is printed to the screen. Danny McGee says, so world exclamation point must be a macro. Maybe. That's maybe true. Third, you see the hello world string. Oh, I already read that. The string is printed to the screen. Fourth, we end the line with a semicolon, which indicates that this expression is over, and the next one is ready to begin. Most lines of Rust code end with a semicolon. Dandy goes on, the world is pretty big. I think it's fair to call it macro. Okay, you got me there. Compiling and running are separate steps. Yep. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the rustc command and passing it the name of your source file, like this, rustc main.rs. If you have a C or C++ background, you'll notice that this is similar to GCC or CLang. After compiling successfully, Rust outputs a binary executable. On Linux, Mac OS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. Sure enough, it's right there. On Linux and Mac OS, you'll see 2 files. With PowerShell on Windows, you'll see the same 3 files that you would see using CMD. What? That went over my head, but it's Windows stuff, so I don't think it matters. This shows the source code file with the .rs extension. There you go. There you go. The executable file, main.exe Windows, but main on all other platforms. And when using Windows, a file containing debugging information with the .pdb extension. From here, you run the main or main.exe file like this, ./main or /main on .exe on Windows. If your main.rs is your hello world program, this line prints hello world to your terminal. Yep, we saw that there. So it works. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running the program as separate steps. Rust is an ahead-of-time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it without even having Rust installed. If you give someone a .rb, .py, or .js file, they need to have a Ruby, Python, or JavaScript implementation installed, respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. Just compiling with rustc is fine for simple programs, but as your project grows, you'll want to manage all of the options and make it easy to share your code. Next, we'll introduce you to the cargo tool, which helps you write real-world Rust programs. You mean it gets more real than hello world? Yeah, it does. Of course it does. Hello Cargo. Cargo is Rust's build system and package manager. Most Rustations use this tool. Okay, I love Rustations. That's fun. Use this tool to manage their Rust projects because Cargo handles a lot of tasks for you. such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. Danny McGee says, what if I want to write Unreal programs, like Unreal Engine 4? I'm afraid maybe you can't do that in Rust, I don't know. What language Unreal Engine, is that C#? I'm just guessing there, I don't remember. C++, okay, gotcha. The simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust for some other means, check whether Cargo is installed by entering the following into your terminal. Cargo version. Cargo 1.64.0. Neat. If you see a version number, you have it. Do you see an error, such as command not found? Look at the documentation for your method of installation to determine how to install Cargo separately. Creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your projects directory, or whatever you decided to store your code. Then on any operating system, run the following. Danny McGee tells us there should be a cargo room command. Let's just see what's going to happen. No cargo room. Bad. Okay, what we are going to do is cargo new hello HELOO cargo. Created binary application hello cargo package. Okay. The first command, it's cd hello cargo. Hey, we have git. That's nice. Didn't see that coming. Where was I? The first command creates a new directory and a project called Hello Cargo. We've named our project Hello Cargo, and Cargo creates its files in a directory of the same name. Go into the Hello Cargo directory and list the files. Let's do ls. You'll see that Cargo has generated 2 files and 1 directory for us. A cargo.toml file. Wait a second. Okay, I was in the wrong. I think I did that in the wrong place. So let's back up. Navigate back to your projects directory, cd ... so we're in projects. Then on any operating system, run the following: cargo new hello cargo. Created binary application hello cargo package. Go into the hello cargo directory and list the files: cd hello cargo ls. I only see 1 file. You see that Cargo has generated 2 files and 1 directory for us: a cargo.toml file and a source directory with a main.rs file inside. Oh, okay. Let's do tree. 1 directory, 2 files. Got it. It has also initialized a new Git repository along with a git ignore. Sure enough. Git files won't be generated if you run cargo new within an existing Git repository. You can override this behavior by using cargo new --vcs =git. Note, Git is a common version control system. You can change cargo new to reuse a different version control system or no version control system by using the --VCS flag, or in cargo new --help to see available options. Yeah, I'm okay just going forward. Open cargo.toml in your text editor of choice. It should look similar to the code in listing 1-2. Okay, we'll do vim cargo.toml. Package. Name hello cargo, version 0.1.0, edition 2021. Dependencies. Tom's obvious minimal language. That's a good name for a... Oops. That's a good name for a language format. This added a comment here. See more keys and their definitions at https:/doc.rustlang.org/cargo/reference/manifest.html. Not sure what that's about, but let's move on. The first line, package, is a section heading that indicates the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines set the configuration information Rust needs to compile your program: the name, the version, and the addition of Rust to use. But we didn't need any of that when we compiled Hello World in the previous chapter. Huh. We'll talk about the addition key in Appendix E. Oh, so each of these are a key. Maybe I should read about TOML. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in Chapter 2, so we'll use this dependencies section then. Now, okay, we can close this. What's happening over here? Nothing. We can just exit that. Cargo room. I just saw that again. That's fun. Now open source/main.rs, then src/main.rs. Oh, it gave us the hello world stuff. Neat. Cargo has generated a hello world program for you, just like the one we wrote in listing 1-1. So far, the difference between our project and the project Cargo generated are that Cargo placed the code in the source directory, and we have a cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top-level project directory is just for README files, license information, configuration files, anything else not related to your code. Using Cargo helps you organize your projects. There's a place for everything, and everything is in its place. If you started a project that doesn't use Cargo, as we did with Hello World project, you can convert it to a project that does use Cargo, move the project code into the source directory, and create an appropriate cargo.toml file. Building and running a Cargo project. Now let's look at what's different when we build and run the Hello World program with Cargo. From your Hello Cargo directory, build your project by entering the following command, cargo build. Compiling Hello Cargo v0.1.0 users blah blah blah. Finished dev unoptimized plus debug info targets in 0.59 seconds. This command creates an executable file in target. Let's see about target. Oh yeah, we've got a target directory. Let's go into target, see what we got. Cache.dir.tag and debug. Can I read cache.dir.tag? Signature, blah, blah, blah. This file is a cache directory tag created by Cargo. For more information about cache directory tags, see whatever. cd debug. Build, deps, examples, hello cargo.d, incremental. Interesting. Lots of stuff. Let's go back to our Hello Cargo directory. If all goes well, Hello World should be printed to the terminal. Running cargo build for the first time also causes... This cargo build command creates an executable file in target/debug/hello-cargo or target/debug.hellocargo.exe on Windows rather than in your current directory. Because the default build is a debug build, Cargo puts the binary in a directory named debug. You can run the executable with this command. So we do dot/target/debug/hello-cargo. Hello world. It works. If all goes well, hello world should print to the terminal. Running cargo build for the first time also causes Cargo to create a new file at the top level, cargo.lock. Oh. Sure. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. Let's just see what's in it right now. This file is automatically @generated by Cargo. It is not intended for manual editing. Version = 3. Package name = hello cargo. Version 0.1.0. We just built a project with the cargo build and ran it with dot/target/debug/hello-cargo, but we can also use cargo run to compile the code and then run the resulting executable all in one command. Cargo run. Finish dev on optimize plus debug info targets in 0.00 seconds, probably because they were already there. Let's vim source / main hello. Now let's see how it does. Cargo run. 0.2 seconds. Compiling hello cargo v 0.1.0. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path of the directory, so most developers use cargo run. Notice that this time we didn't see any output indicating that Cargo was compiling hello cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild but just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it and you would have seen this output, which we saw here. Compiling, finished, running, hello world. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles, but doesn't provide an executable. Okay, we'll try that. Cargo check, checking hello, finished. Why would you not want an executable? Often cargo check is much faster than cargo build. It took half the time. Because it skips the step of producing an executable. If you're continually checking your work while writing the code, pardon me. If you're continually checking your work while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many restations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap what we've learned so far about cargo. We can create a project using cargo new. We can build a project using cargo build. We can build a run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our codes, Cargo stores it in the target/debug directory. An additional advantage of using Cargo is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux and macOS versus Windows. That's nice. Building for release. When your project is finally ready for release, you can use cargo build -- release to compile it with optimizations. This command will create an executable in target/release instead of target/debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build -- release and benchmark with the executable in target/release. Cargo is convention. With simple projects, cargo doesn't provide a lot of value over just using Rust C, but it will prove its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using Git, change to that project's directory, and build. Git clone example.org/someproject, cd someproject cargo build. Summary: you're already off to a great start in your Rust journey. In this chapter, you've learned how to install the stable version of Rust using RustUp, install the latest stable version of Rust using RustUp, update to a newer Rust version, open locally installed documentation, write and run a Hello World program using Rust C directly, create and run a new project using the conventions of cargo. This is a great time to build a more substantial program to get used to reading and writing Rust code. So in Chapter 2, we'll build a guessing game program. If you'd rather start by learning how common programming concepts work in Rust, see Chapter 3, then return to Chapter 2. What I want to do is build a release version of Hello Cargo. So I'm going to change the code. source/main.rs, print hello, comma, cargo, then Rust build, it was -- release, I think. Oh, not Rust, huh. Cargo build -- release. Compiling. Finished released optimized targets in 0.1. So let's look at tree now. There's gonna be some more stuff. Whoa, lots of stuff. Why is there so much stuff? Is that including Git? Oh, it's all the debug stuff. All right, hold on. CD release, let's see. Oh, even release has all this other stuff. Anyway, let's do /hello cargo. Hello cargo. Cool. I am going to move on to chapter. Well, we're almost out of time on this Pomodoro. So I'm going to pause and add. Oh, yep, there it is. Anyone in the chat have questions on anything we've gone over? I think the book explains it pretty clearly, so I wouldn't expect any questions. But maybe I shouldn't be so discouraging of questions by saying that. Let's hit the BRB screen. And I, in fact, will be right back. This is a little off-center. Let's fix that. It doesn't want to sit up straight. There it goes. Where did the music go? Oh, we're just in a quiet track. Let's skip ahead of that one. Okay, that was 5 minutes. That time I took the whole 5 minutes. Let's get back to the main scene. And let's proceed bravely on to chapter 3. Programming a guessing game. I may not make it through this whole chapter, but I'll give it a good start before I call it for the night. Let's bring that up to there. Programming a guessing game. Excuse me. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You learn about let, match, methods, associated functions, using external crates, and more. In the following chapters, we'll explore these ideas in more detail. In this chapter, you'll practice the fundamentals. We'll implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random number between 1 and 10. It will then prompt the player to enter a guess. After the guess is entered, the program will indicate whether the guess is too high or too low. If the guess is correct, the game will print a congratulatory message and exit. Okay, so it's a binary search. Setting up a new project. What's it doing? Nothing. I was imagining that. To set up a new project, go to the projects directory that you created in chapter 1 and make a new project using cargo like so. Okay, cargo new guessing game. Created binary application guessing game package. 3D guessing game. The first command, cargo new, takes the name of the project, guessing game, as the first argument. The second command changes to the new project's directory. Look at the generated cargo.toml file. File name cargo.toml. Okay, let's do it with vim so we have syntax highlighting. Vim, ls cargo.toml. Okay, vim cargo.toml. Package. Name equal guessing game, version 0.1.0, edition 2021. Why does it say 2021 for edition? Shouldn't it say 2022 at this point? See more keys and their definitions at blah blah blah. Okay, dependencies. As you saw in chapter 1, Cargo generates a new Hello World program for you. Check out the source/main.rs file. All right, let's do that. Source/main.rs. Function main, parens, brace, println, exclamation point, hello world. Okay. Now let's compile this hello world program and run it in the same setup using the cargo run command. cargo run. Hello world. Okay, that worked. The run command comes in handy when you need to rapidly iterate on a project, as we'll do in this game, quickly testing each iteration before moving on to the next one. Reopen the source/main.rs file. You'll be writing all the code in this file. Let's give Vim a little more room. Okay, Vim src/main.rs. Processing a guess. The first part of the guessing game will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess. Enter the code in listing 2.1 into source/main.rs. Alright, let's just delete everything and start fresh. Use std : io. I assume they'll explain that to us. Function main, paren 1, 2, 3, 4, print ln exclamation point because it's a macro. Guess the number exclamation point. They do like exclamation points. Print ln exclamation point. Please input your guess period quote and semicolon. Let mut guess equals string : new. What do we have here? Nothing. Nothing of interest. I wonder what mut is. I'm sure it'll tell me. io : std in dot read line. Oops. And mut guess dot expect failed to read line. This is feeling a little bit intimidating, but we'll see how it goes. Println exclamation point quote you guessed colon brace guess and brace quote paren semicolon closing brace. Listing 2-1 code that gets a guess from the user and prints it. This code contains a lot of information, so let's go over it line by line. That sounds good to me. To obtain user input and then print the result as an output, we need to bring the IO input-output library into scope. The IO library comes from the standard library known as std. That's this use std : io. By default, Rust has a set of items in the standard library that it brings into the scope of every program. This set is called the prelude, and you can see everything in it in the standard library documentation. We'll leave that for later, but maybe I'll open the window just to have it. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Using the standard : io library provides you with a number of useful features, including the ability to accept user input. As you saw in Chapter 1, the main function is the entry point into the program. Function main paren brace. The fn syntax declares a new function. The parentheses indicate there are no parameters, and the curly bracket, curly brace I think is what they're called, starts the body of the function. As you also learned in Chapter 1, println is a macro that prints a string to the screen. Println guess the number, println please input your guess. This code is printing a prompt stating what the game is and requesting input from the user. Storing values with variables. Next, we'll create a variable to store the user input like this. Let mut guess equals string : new parens semicolon. Now the program is getting interesting. There's a lot going on in this little line. we use the let statement to create the new variable. Here's another example. Let apples equal 5, semicolon. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. We'll be discussing this concept in detail in the variables and mutability section in chapter 3. To make a variable mutable, we add mut before the variable name. Oh, okay, mut for mutable, that's what that was. Let apples equals 5, semicolon is immutable. Let mut app bananas equal 5 is mutable. Note, the // syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. We'll discuss comments in more detail in chapter 3. Sure. Returning to the guessing game program, you now know that let mut guess. Should I be saying mut guess or mute guess? Any opinions on that one? I kind of like mut. We'll introduce a mutable variable named guess. The equal sign equal tells Rust we want to bind something to the variable now. On the right hand of the equal sign is a value that guess is bound to, which is the result of calling string : new, a function that returns a new instance of a string. String is a string type provided by the standard library that is a growable UTF-8 encoded bit of text. The : syntax in the : new line indicates that new is an associated function of this string type. An associated function is a function that's implemented on a type, in this case string. The new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. In full, let mut guess equals string : new parens semicolon line has created a mutable variable that is currently bound to a new empty instance of a string. Woo! Receiving user input. Recall that we included the input-output functionality from the standard library with use standard : IO on the first line of the program. Now we'll call the standard in function from the IO module, which will allow us to handle user input. IO standard in parens .readline at mute guess. Guess I'm saying mute now. If we hadn't incorporated the IO library with the use stdio at the beginning of the program, we could still use the function by writing this function call as standard in std : IO : std in. The standard in function remains an instance. The standard in function returns an instance of standard IO standard in, which is a type that represents a handle to the standard input for your terminal. Next, the line .readline at mute guess calls the readline method on the standard input handle to get the input from the user. We're also passing at mute guess as the argument to readline. Tell it what string to store the user input in. The full job of readline is to take whatever the user types into the standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change that string's constant. So that the method can change the string's content. The AND indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot about these details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write at mute guess rather than at guess, and mutable guess rather than and guess to make it mutable. Chapter 4 will explain references more thoroughly. That's good, because I'm feeling a little uncertain about them. Handling potential failures with the result type. We're still working on this line of code. I guess it's technically one line because it's all before one semicolon, even though we typed it on 3 separate lines. We're now discussing a third line of text, but note that it's still part of a single logical line of code. The next part is this method. .expect failed to read line. We could have written this code as io : standard in parens .readline at mute guess .expect failed to read line. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line in other whitespace to help us break long lines when you call a method with the method name syntax. Now let's discuss what this line does. As mentioned earlier, readline puts whatever the user enters into the string we pass to it, but it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Okay, let me read that again because I feel like that went over my head. As mentioned earlier, readline puts whatever the user enters into the string we pass to it. So readline puts stuff into this @mute guess. But it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK and error. The OK variant indicates the operation was successful, and inside OK is the successfully generated value. The ERR variant means the operation failed, and ERR contains information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. If this instance of result is an error value, expect will cause the program to crash and display the message that you pass as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of result is an OK value, expect will take the return value that OK is holding and return just that value to you so you can use it. In this case, that value is the number of bytes of the user's input. If you don't call expect, the program will compile, but you'll get a warning. Cargo build, compiling guessing game v0.1.0 file projects guessing game. Warning unused result that may be used. 10. In source main rs10.5 io : standard in .readline at mute guess semicolon. Node. Warn unused must use on by default. This result may be an error variant which should be handled. Warning guessing game, bin guessing game, generated one warning, finished dev, unoptimized, debugging target in 0.59 seconds. Rust warns that you haven't used the result value returned from readline, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write an error handling, but in our case, we just want to crash this program when a problem occurs so we can use expect. You'll learn about recovering from errors in Chapter 9. Printing values with Println placeholders. Aside from the closing curly brace, there's only one more line to discuss in the code so far. Println, you guessed num. You guessed curly brace guess. This line prints the string that now contains the user's input. The set of curly braces is a placeholder. Think of curly braces as the little crab pincers that hold a value in place. Oh, that's cute. You can print more than one value using curly brackets. The first set of curly brackets holds the first value listed after the format string. The second set holds the second value, and so on. Printing multiple values into one call to println exclamation point would look like this. Let x equal 5, let y equal 10, println exclamation point, x equal curly braces and y equal curly braces, comma x, comma y. This code would print x equal 5 and y equal 10. Testing the first part. Let's test the first part of our guessing game. Run it using cargo run. Okay, quit. Oh, I haven't written it. Write quit. Cargo, guessing game, cargo run. Please input your guess. Say 5. You guessed 5. And that's the end of the program. Oh, they guessed 6. I wonder which was the better guess. Generating a secret number. Next, we need to generate a secret number that the user will try to guess. The secret number should be a different every time the game, so that the game is more fun to play more than once. We'll use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include a random number functionality in the standard library. However, the Rust team does provide a rand crate with said functionality. Okay. Using a crate to get more functionality. Remember that a crate is a collection of Rust source files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code intended to be used in other programs that can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml file to include the rand crate as a dependency. Open that file now. So file name cargo.toml, vim cargo.toml, and add the following line to the bottom beneath the dependencies section header that Cargo created for you. Be sure to specify rand exactly as we have it here with this version number, or the code examples in this tutorial may not work. Okay, rand equals quote 0.8.3 quote. Okay, we'll just write for now. In the cargo.toml file, everything that follows a header is a part of that section that continues until another section starts. In the cargo.toml file, everything that follows a header is part of the section until another section starts. Sure. In dependencies, you tell Cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the rand crate with a semantic version specifier 0.8.3. Cargo understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. The number 0.8.3 is actually shorthand for caret 0.8.3, which means any version that is at least 0.8.3 but below 0.9.0. Cargo considers these versions to have public APIs compatible with version 0.8.3, and this specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any version 0.9.0 greater is not guaranteed to have the same API as what the following examples use. Now, without changing any of the code, let's build the project as shown in listing 2.2. All right, write quit, cargo build. Updating crates.io to index. Fetch. All right, we'll just let this roll. Wonder what else it could be telling me if I expanded it. Okay, got it. You may say different version numbers. That's right, rand 0.8 be 0.8.5 as opposed to the 0.8.3 I said. You may see different version numbers, but they will all be compatible with the code thanks to Semver. Different lines depending on the operating system, and the lines may be in a different order. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. Cool. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed rand as a dependency, Cargo also grabbed other crates that rand depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run Cargo build again without making any changes, you won't get any output aside from the finished line. Let's try that. Yeah, just the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. If you open up the source/main.rs file, make a trivial change, and then save it and build again, you'll only see 2 lines of output. So let's make a trivial change, bim source/main.rs. Or let's add a line. I don't know if that's even allowed, but let's try it. Cargo build. Okay. Compiling guessing game finished it. These lines show Cargo only updates the build with your tiny change to the source/main.rs file. Your dependencies haven't changed, so Cargo knows that it can reuse what it has already downloaded and compiled for those. Ensuring reproducible builds with the cargo.lock file. Cargo has a mechanism that ensures you can rebuild from the same artifact every time you or anyone else builds your code. Cargo will use only the versions of the dependencies that you specified until you indicate otherwise. For example, say that next week version 0.8.4 of rand crate comes out, and that the version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.lock file the first time you run Cargo builds, so we now have this in the guessing game directory. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria and then writes them to the cargo.lock file. When you build your project in the future, Cargo will see that the cargo.lock file exists and use the same versions specified there, rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 0.8.3 until you explicitly upgrade, thanks to the cargo.lock file. Because the cargo.lock file is important for reproducible builds, it's often checked into source control with the rest of the code in your project. Updating a crate to get a new version. When you do want to update a crate, Cargo provides the command update, which will ignore the cargo.lock file and figure out the latest versions that fit your specifications in cargo.toml. Cargo will then write those versions to the cargo.lock file. Otherwise, by default, Cargo will only look for versions greater than 8.3 and less than 9.0. If rand crate has regressed due to versions 0.8.4 and 0.9.0, you would see the following if you saw rand cargo update. Let's just try cargo update. Cargo ignores the 0.9.0 release. At this point, you would also notice a change in your cargo.lock file, knowing that the version of rand you are now using is 0.8.4. To use rand version 0.9.0 or any version in the 0.9.x series, you'd have to update the cargo.toml file to look like this instead. Dependencies rand equals quote 0.9.0 end quote. The next time you run cargo build, cargo will update the registry of crates available and reevaluate your rand requirements according to the new version you have specified. There's a lot more to say about cargo and its ecosystem, which we'll discuss in chapter 14, but for now that's all you need to know. Cargo makes it very easy to reuse libraries, so rustaceans are able to write smaller projects that are assembled from a number of packages. And there's the end of that 30-minute Pomodoro. And I'm feeling like I've done enough streaming for tonight. Almost 2 hours. That's not a whole lot, but it's something. So we're gonna call it for tonight. I'm gonna call it for tonight. Thanks for watching, and see you around on the internet.